about this. My mic is on. Hello? Oh, there we go. So where is that quiz? There it is. Make a quick copy of this. All right, so the polynomial function, what is the degree? So we take this x squared, this x cubed, right? So it looks like an x times an x squared times an x cubed, which is x to the sixth, adding the exponents. So the correct answer here was 6. What is the leading coefficient? Well, we look at all the numbers that would have been in front of these, right? There's a 1 there, there's a 1 in front of that x, there's a 1 in front of this x. So if we would have multiplied those all together, we would have just had a 1, right? It's like the 1x to the sixth. So the leading coefficient was 1. All right, what is the left and right hand behavior? You have an even degree and a positive leading coefficient, right? Which means that the left and right hand sides both go up. Okay? It goes off of this right here, that piece right there. So look, here's a way to remember this. This might help you. Does everybody here know what x squared looks like? Looks like a parabola goes up, right? Isn't that an even degree with a positive leading coefficient? Okay. Do you know what negative x squared looks like? Yes, going down. That's an even degree negative leading coefficient. Now, you have to remember now what x cubed looks like. Do you remember what x cubed looks like? It's one of your basic functions you're supposed to know. Left side went down, right side went up. So this is an odd degree positive leading coefficient. If you put a negative in front of it, that's an odd degree negative leading coefficient. It would go like this. So that's a way you can kind of remember these. Now, on the test, you're allowed to have a cheat sheet for that. Okay, but I wanted to see how many of you could recall that from doing your... Yeah. Okay. Listed are the x-intercepts and behavior of the graph at the x-intercept. Circle the one that's true for this function. So we have 3 x-intercepts. You would have to set each of these factors, x equal to 0. You'd have to set this factor, x plus 3 equal to 0. You'd have to set this factor, x minus 4 equal to 0. That would give you 3 solutions. The first solution would be 0. The second one would be negative 3. And then the last one would be 4. So what I want to make sure you're doing is you're not looking at the sign here. It's not, the x-intercept is not positive 3 and negative 4. It's actually the opposite of that, right? It's negative 3 and positive 4. And 0, well, 0 is not positive or negative, so it doesn't matter. So then you look at the power on each factor. The x is to the first power, that's odd. The x plus 3 is to the second power, that's even. The x minus 4 is to the third power, that's odd. So what happens if you have an odd power? Cross. Even power? You bounce or touch. So which one of these is it? See? So at 0 you cross because 0 is to the odd power. At negative 3 you bounce because negative 3 is the x-intercept. It's to the second power, so you will bounce there. Positive 4, right, to an odd power. So the reason why I chose these numbers, look, this x-intercept is 4, right? That's an even number. That has nothing to do with bouncing and crossing. But people will look at the number and say, oh, 4 is even, so it's going to bounce. That's not the case. You look at the power on the factor to determine the bouncing and the crossing. Understand? Questions? Okay, that's it. All right, let's move on. All right, so we had ended class. I had graphed a couple of these, and we didn't really talk too much about this. Right? We did this one, didn't we? Yes, we did do that. But let me give you something similar to that with this example 5.1 point 11, all right? Construct a polynomial function with these characteristics. You have to have zeros at -4, 5, and 1. It has to have a degree of 3, and the graph has to go through this point, all right? So let's see if we can do that. See if we can make this happen. Not sure. Oh, you know what? A what? This is the notes from last class. These are notes from last class. I discovered this feature of, I guess, Windows. It's a Windows feature where you can do a screen clipping. If you just hit the Windows key and S, watch, and then I can just like highlight whatever, and that's copied to my clipboard, and then I can paste it. Just FYI, anyone who ever needs to do that. Okay, so we want to do this, right? So what can you tell me about these zeros? I mean, what do the zeros give you? This is important because we're going to talk about this today more. The zeros give you, those are x-intercepts, but we're supposed to construct a function from this, right? I'm supposed to construct a function f of x. And those zeros tell me the what's of this function. The factors, right? The factors. The fact that -4 is an x-intercept means that x plus 4 is a factor, right? Because if I plug -4 in right here, this zeroes out, right, and creates a 0 for the function. This +5 creates a factor of what? X minus 5. And then this this 1 gives me a factor of what? X minus 1. Okay, I have to be a third-degree polynomial. Is this a third-degree polynomial? Yes, if I multiply these together, they would all be, you know, x, we get x cubed, so I'm good with that. The only condition left is that I have to contain this point. So tell me if this makes sense to you. This function, so far, has these zeros, is a degree 3, but there might be a number out here. I'm going to call it a. Like, for example, maybe that's 5. If I put a 5 here, does that change my x-intercepts? No. Does it change the degree? No. If I just put 5 out there. I could have any number out there, couldn't I? And I would still have the same x-intercepts, still same degree. So what I'm going to say is I know that the function looks like this, with the exception that there might be a number out here that I'm not quite sure of. Understand? Now, this point has to live on the graph. So that means when I plug in 2, right, for x, sorry, I should have put, if x is equal to 2, what should happen is the function, when I plug in 2, should spit out what? -18. So that means that if I replace all my x's with 2's, this should be -18. So I'm going to make the left side of this -18. That must equal, let's see, 2 plus 4, 2 minus 5, 2 minus 1 times a. And what I have here now is an equation, don't I? This equation has only one variable in it, a, which means I can solve for a, which means I'm going to be able to determine exactly what a is. So let's do some multiplication here after we add these up. 2 plus 4 is 6. So we get 6 times 2 minus 5, -3, 2 minus 1, 1, and then times a. But 6 times -3 times 1 is -18. Yeah, so it's going to just turn out to be, after we divide both sides by -18, that a is 1. So now I'd rewrite what the function is. See, now I've locked down what a has to be. Does that make sense? What I'll do is, well, let me write the function down as our final answer. It is x plus 4 times x minus 5 times x minus 1. Yeah, you'd put it right here. Yeah, good question. Thank you. So let me go look at that demo I had from last class. Where is it? Right here. This will be good enough. We said that we had a degree 3 polynomial, right? We said that one of the x-intercepts was what? -4. The other one was 5 and then 1. Okay, and so this is what we think it is, right? Right here. And we wanted it to go through the point 2, -18. Ah. So you can see here, this is 1, 2, 3, 4, 5. So if I go out to 2, I go down. Here's -18 right there. So hopefully that looks right to you. That's the only function that does that. If I were to change this by maybe putting the number in front of it, see here's a 4 I put in front. It still goes through the same x-intercepts, but now when you plug in 2, it's not -18, it's something else. Got me? So there's an infinite number of functions that go through those 2 x-intercepts, or those 3 x-intercepts. There's a bunch of them, right? All of these have the same x-intercepts. They're all third-degree polynomials. But with that one condition that had to go through 218, locks it down. There's only one that can be that way. All right? Okay, so that's the end of those notes. Does that kind of clarify? Okay. All right, so today I have the notes I handed to you. You need a copy, sir? Who needs a copy of these? All right, so I told everyone when this course began that I haven't taught this 1414 well ever, right? I told you all that. And so this is a book that I have never used before. This is a layout of the course that is different, a little different than what I'm used to, or what I think is more natural. So I've decided to kind of make my own section, okay? It's taking bits and pieces from sections that we're going to see later and giving them to you now because I think it's better to have it now. Later on we'll get more rigorous and I'll give you a bunch of definitions. For now we're just going to get the highlights of those sections and bring them into today. So I'm calling this section Section F for factoring, all right? Factoring polynomials, all right? When you started this class, I told everyone that, I expected everyone can factor a trinomial, right? Difference of squares, difference of cubes, all these things that, grouping, right? Those are like the methods that we are used to hopefully working with. But there is another way to factor polynomials, a very powerful way. In my opinion, you should be taught this from the very beginning, but it's not taught this way, and I'm not quite sure why. Maybe you'll appreciate it, who knows? So we've seen, sometimes we run into polynomials which cannot be factored using our standard techniques. We have not seen this yet, okay? Here's an example. If I asked you to sketch this right now, all right? If I asked you to sketch it, you go through all the steps. Step A, is it a polynomial? Yes. Step B, left-right behavior. I'm going off of last class notes, right? Step B, left-right behavior. So what would this one do? Both up, both down, left down, right up, right down? What? Left down, right up, okay? And then the next step would be what? X-intercept, so you set it equal to 0. Good luck. It's not going to happen for you, all right? Because you would look at this, the first thing you would do is GCF. There is no greatest common factor, right? So the next thing you would look at is possibly grouping. So let me show you why that's not going to work. All right, so let me start a new page here. If we had this, and I tried to do grouping, so what I'm doing is, I don't want to write down all the other things right now, so I'm just going to say I'm at the step of x-intercepts, right? I want to set that equal to 0. That's step C. So I would do x cubed plus 8x squared plus x minus 42 equals 0. So I try and factor it. 4 terms is grouping, yeah? You've heard that before? So how do we do grouping? We split it down the middle, and we try and pull a GCF out of the first 2. Do we have a GCF out of the first 2? X squared. So I pull that out, x squared. What's left when I pull an x squared? X plus 8. And now out of the other one, you can't really pull anything out, can you? You can pull a 1 out. Okay, so if I did a 1, let me do that, I'd be left with an x minus 42, wouldn't I? Now, grouping only works if what? These have to match. Those have to match for grouping to work, because the next step is to pull that common thing out, and they're not common. So grouping fails. Nope. There's nothing you can do as far as grouping is concerned. It fails. So grouping fails. Now, since we're used to using grouping, and it's been successful in the past, if we run into 4 terms, we do want to try grouping first. But if it fails, we need to have a way of doing it. So the question becomes, does it even factor? Is it even possible to factor this? Some things can't be factored. All right? Some can't. I'll give you an example of something that can't be factored. X squared plus 4 cannot be factored. X squared minus 4 can, right? Difference of squares. X squared plus 4 cannot be factored over the real numbers. So the only way to factor that means we have to bring in imaginary numbers, and it's nah. All right? So not every polynomial will factor. With me? So you may think here, all right, well, look, grouping failed. Hey, this thing doesn't factor. But you're wrong. And so let's look at the notes. Where are my notes? There we go. I proved to you that it can be factored. And the way I do it is here's the answer, right? This is what we're trying to factor. Here's what it factors to be. Now, don't ask me how I got there yet, all right? But I'm going to show you that this is equal to this. So what I did is I take these 2, and I expand those, right? I multiply those together using that little FOIL thing, and that would give me this. I collect like terms right there, so I put the 7x and the 3x together. That gives me 10x. And now how do I multiply this times this? X goes through, right? X here, X here, X here. That gives us these first 3 terms. And then you take your negative 2 and multiply that through, and you get these 3 terms. Put it all together, and voila. You have this thing that I was trying to get you to factor, right? And I hope you're convinced this does factor. It's these 3 things. Question, how in the hell do you get there, right? What's that? Nope, not on this one. No. Hey, you know, it might work that way, but no, we're not going to approach it that way. So how in the world are we going to factor this, right? How are we going to do it? All right, so to do this, we have to build up some ideas first, all right? So that's our main goal for the day, is to be able to factor something like that. Before we can do that, we got to do some other stuff, all right? So it's like we're going to go build a shed. Before we do that, let me show you how to use the saw and everything, and then we'll go build a shed, all right? Division. Division, good old division from way back when, tells us a lot of information, more than you thought it told you. So let's see if you can follow this. If I say 15 divided by 3 is 5, we'd all agree? Yes? Now, because 15 divided by 3 is 5, you could also extrapolate from that 15 must be 5 times 3. Yes? If 15 divided by 3 is 5, that means that if I multiply this 3 times this 5, I should get back this. Yes? In other words, I've in some way factored the number 15, haven't I? I've taken 15 and I've broken it down as 2 things being multiplied. Okay, here's another one. 90 divided by 2 is not 30. Why in the world would I put that? I need to fix that. So I either change that to a 6 or I change the other one to a 45. Okay, you agree with that? I told you it's going to get crazy. All right, so 60 divided by 2 is 30. I hate when I do things like that. Now I got to go fix everything. 60 divided by 2 is 30, which means that you could rewrite 60 as 30 times 2. So we've, again, found kind of a way of breaking 60 down into to a product. Okay, what about this one? 15 divided by 4. It doesn't go in evenly, right? We would have some decimal. It would be like, goes in there like 3 times with like something left over. So it's not going to be possible for us to say that 15 is 4 times a nice number, right? I mean, it is. There is a number that would work right here. 15/4 would work. But there's not a nice number, right? Like up here, 30 and 2, 5 and 3. The question is there a nice number here? No. All right, do y'all follow that? So the key here was with remainder, okay? This one, when you divide that in, there's a remainder. There's something left over. With this one, when I said 30, I meant 30. There's nothing, hanging off the end there. Same thing with this, 5 and no more. All right, so now let's start to see how we're going to bring that into what we're doing. Let's take a look at x squared minus x minus 2 over x plus 2. Do you agree that the top is a polynomial? Yes? X squared minus x minus 2. Now, just for a moment, act like this bottom piece is not here. The part in blue up there is what I want you to focus on. If I asked you to factor that today, right now, you should be able to factor that. That's a trinomial. It factors to be x minus 2 times x plus 1. All right? But we're just keeping that in the back of our mind. What I'm trying to say is, when we're doing these problems, I want you focusing more on the numerator than the denominator. Okay. Now, knowing that it factors, right, like this, knowing that it does. Yes, I did. You know what? What? Yeah, I'm going to have to make this a plus x. Change that to a plus. Make sure. Oh, and then this one's a plus 2. Man, I did this yesterday. I wasn't on meds or anything. No, I'm just kidding. I'm not on meds to begin with, but I don't know. I was in my office. I was taking my time. I don't know. Sometimes it just doesn't happen. All right. Anywhere you see that x squared minus x minus 2, change it to a plus. God, it's all over the place. Okay. All right. So you got to work the kinks out here. All right, so we can factor the top. That okay with the factoring? And then we can cancel these factors, right? When we cancel those factors, all we're left with is the x minus 1 on top. So what does this allow us to say? That this times this, right, must be that top piece. Like we broke down the 90 or the 60. That means the 30 and the 2, right? The 30 and the 2 multiply to be that 60. By coming up with this, we can say this and this multiply to be whatever that top was. So this is the conclusion. Does that make sense? Now, I mean, it's kind of a circular thing here. We knew that to begin the problem. I mean, we actually knew that it broke down to that. But I want you to see how if you can somehow take this and divide this in, whatever the answer is here, that times this should be the top. Okay? That's all that matters. Let me just keep going, and then you'll hopefully see where I'm going with this. Okay, so if we're going to do this, if we want to find this answer, we're going to use what's called long division. Well, what's wrong with that? Sounds long, yes, I know. How many of you have to take Cal 1? Cal 2? Cal 2? Okay. I show y'all Cal 2 stuff all the time, don't I? I know you don't like, I know you don't like, you're not liking this idea of long division. No, I'm just showing you right here real quick that this problem right here, the first step was long division. You just had to do that real quick, and after that, you just work through the rest of the problem. So long division is never going to go away, so you may as well just come to appreciate it now and just be okay with it, all right? Okay, so what I'm going to do right now is I'm going to do this problem right here. I'm going to get the answer that we know it is, right, x minus 1? But I'm going to do it without factoring, without acting like I did not know how to factor. Understand? Okay, so here I go. I'm going to take, hopefully, the correct version of this here. I'm going to try and do x squared plus x minus 2. I'm going to divide that by x plus 2. Does everyone understand? I'm going to act like I can't factor that, so I'm like, what do I do? Well, long division. So the way long division works is this. You take the numerator, and that's going to be the thing that goes in your division box. Make sure it is in descending order. Highest power of x down, from left to right. Outside the division box, you put the denominator, and you make sure it's in descending order, x plus 2. If you want underneath this, I'll write an analogy to this. 50 divided by, I don't know, 4, let's say. Then what you would do is you would do 50 in here, right? You do 4 here. This is like way back, old school, right? Then you'd say to yourself, what? How many times does 4 go into 5? And you would say what? Once. And then you would multiply 1 times 4. Bring it under here, put that underneath the 5. Then you would subtract that, wouldn't you? And that would leave you with the what? 10. And then you'd say, how many times does 4 go into 1? It doesn't. How many times 4 go into 10? Twice, right? 2 times. Then you multiply 2 times 4. That gives you 8. You would subtract this row, and you'd get what? 2? So your remainder would be 2. Does that look kind of familiar? Maybe you did it a different way. But what the most important thing is the process. We put the numerator in the division box, the denominator outside, and then we asked ourselves, what do I multiply this by to get something here, right? Up here, what we do with long division is we focus all of our attention on the x. We say, what do I multiply this x by to turn it into this first one here, x squared? So what do I multiply x by to turn it into x squared? Just a single x, right? So I'm going to put that x right here. And notice I decided to line this x up vertically above the x here. You don't have to do that. You could put the x anywhere up here, but I like to kind of line things up. Now, what did we do here when we put that 1 here before the 2 was there? After we put 1 here, we did 1 times 4 and put that here, didn't we? So I'm going to do x times what? The whole thing, x times x plus 2. I'm going to be doing x times x plus 2. That's my little scratch work on the side, and I'm going to put that answer underneath here. So let's just do that. What's that multiply to be? X squared plus 2x. So underneath this x squared, I'm going to put x squared. And underneath the plus x, I'm going to put plus 2x. Understand? Make sure you line everything up vertically. Now what we did is after we had the 4 down there, we came in and subtracted it, right? So I need to subtract this row. And when I say subtract, that means it's going to change the signs. So I like to be very exaggerated here. This was a plus x squared, right? It's now going to become a minus x squared, right? That's a big old minus sign. And this plus 2x is now going to become a minus. So I'm going to exaggerate it so that you really see that that sign changed. So what is x squared take away x squared? 0. Okay? And then what is positive 1x take away 2 x's? Negative 1x, right? Or just negative x? So this is going to be a negative x. And then underneath this negative 2, you want to imagine that there's really like maybe a plus 0 here or something. Doesn't matter. There's nothing there, right? I can add or subtract 0. It's not going to change this. This just drops down. Doesn't change signs. It just drops down. Just negative 2. Okay. Now, at this point, we repeat the process. So I go back to the x in front. But now I'm looking and I'm saying, what do I multiply by to get this? Negative x. Negative 1, right? So I put my negative 1 up there. And now I'm going to multiply negative 1 through to this. And I'll do that on the side here. Negative 1, x plus 2. When I multiply that through, what would I get? Negative x. So I should put that underneath this one, right? And then minus 2. And then you come through and subtract that row, which changes the signs to positives. Now you add straight down, you get 0. Negative 2 plus 2 is 0. So you get 0, so you have no remainder. So this is the answer, x minus 1. So I'm going to put up here equals x minus 1. What the conclusion of this is, I mean, this is the answer, okay? That's the answer. If someone asks you to divide these two, that's the answer. But what I want you to gain from this is that what we're really able to say here now is that x squared plus x minus 2 is actually equal to what? X plus 2 times x minus 1. And you could have changed the order if you wanted to, right? You could have put the x minus 1 here and the x plus 2 here. So in some way, this is the answer. In some way, this little thing with the star here is kind of like we factored it. Kind of, right? We figured out a way to factor it. Yeah. All right, so let's see if we can see what sort of issues we might run into here. Gotta do something, man. Go out and just go run down the hall. Do like a couple of sprints back and forth. You'll wake up a little bit. Nah, I don't know if that'll work. All right, so what about this one? We're going to practice these. Let's do x squared plus 2x minus 15 over x plus 5. Would you like to try that on your own? Go ahead. I'll give you 30 seconds. No. See how long it takes you to do that one. While you're doing it, I'm going to work it out up here, but I'm not going to talk. I'm just going to work it out so you can see. There you go. You know what horses are? Go do a couple of horses. We're going to do all of them. Feel free to, if you finish A, move on to B, but I'm sorry? Yeah, we'll have to talk about what we do with that. There's not a remainder on the first one though, right? Okay. We can have a remainder, yes. Just, I haven't done that. I'll do an example. I want to see when everyone's done with A. Who's still working on A? Still working on A? It's okay if you are. Still working? Okay. You got B? Is that what you said? Okay. So you got A? Everyone's good A? Everyone got A here? Got A? Did you get it okay? Yeah, so the answer would be this, okay? Yep. You got A? Yeah? Okay. You got A? Okay, I think everyone has A. All right, so x minus 3. What about B? Do you run into a little bit of an issue on B? We have a remainder. So let me show you how B is going to work when you have a remainder. You have x squared plus 2x minus 15. Then you have x plus 4 out here. What do you multiply by first? X, right? X first. That'll give you x squared plus 4x. Come through and subtract. So what's my next line under here going to be? Negative 2x minus 15. Then I have to multiply x by what to get negative 2x? Negative 2? Not x, just negative 2, right? And then when I multiply that through, I'll have underneath here negative 2x minus 8. Then I come through, change the signs, add down, and I get negative 7. Okay, at this point, this is a very important part of this problem. You cannot turn x into negative 7 easily, all right? Another way to look at it is that the power on this x is bigger than the power on this x. See here, when we were trying to match up with this one, right, negative 2x, the power here and the power here were the same. So I was able to multiply by negative 2. But once the power on this becomes less than the power here, you have to stop. So this is our remainder. So how did we say remainders back in grade school? We put like a capital R and then we put the number, right? That's not, yeah, we're not going to use the capital R in here, okay? What we're going to do is we're going to write next to this, right next to our answer, we're going to write plus, okay, plus the remainder, which is what? Negative 7 over the divisor, x plus 4. You might recall this from a problem like this. Let's do, if I did 13 divided by 4, right? 13 would be here, 4 would be here. How many times is 4 going to 13? 3 times, that's 12. We'd have 1 left over. So you would put remainder 1, right? And then you were taught later that you could write 3 and 1/4. What a lot of students don't realize is that 3 and 1/4, what that actually means is 3 plus 1/4. That's why this notation sucks and we don't use it anymore because it's confusing, right? If I write this, it's called a mixed number. You ever remember hearing that, mixed numbers? We stopped using mixed numbers. We stopped because when I write 3 and 1/4, someone could confuse that with 3 times 1/4, which is not the same thing. And so what this actually means is this. We just don't ever say that. And so it's just bad. We should just take it completely out of math. It's, ugh. Right? What would be better to use if you're going to use, if you want to use a fraction, what would be better is to convert this back into 13/4. Remember how you take the 3 times the 4, add the 1, make it 13 over 4? That's better than writing that 3 and 1/4. So this is, I was helping a student the other day, and he was doing something. Do you remember me telling you the difference between 0 and this empty set? He's in my calculus class, and he was writing the empty set for 0. And I just told him, I said, hey, you know, that's not 0. You might want to change that. I said, it's kind of like if someone's walking around with toilet paper on their shoe or something. You know, it's like you don't want to just let them keep walking around, you know. You just kind of go up to them and say, hey, you got a little something on your shoe. Like, same thing here. You don't want to really be using this anymore. Like, if you get into pre-cal and cal 1, you're still using mixed numbers. people are going to look at you like, you're just not there yet. You just, you haven't reached that next level. Does that make sense? What the hell, man? I'm ready for the weekend. All right, let's look at C. C is tricky. C is tricky. X cubed minus 8 over x plus 2? Minus 2? What did I put on here? Minus 2. It should be minus. That's fine. All right, so with the division box, right, I'm supposed to put the numerator and I'm supposed to put it in descending order, which it is. Now, please don't write this down. Just watch me, because I want you to see the incorrect way to do it and how I'm going to run into a problem. If I just write x cubed minus 8, then out here x minus 2, that seems like I'm doing everything correct. Then I ask myself, what do I multiply x by to get this, right? So what do I multiply x by? X squared. So I put that on top, fine. And now I'm supposed to multiply that x squared through this, right? So if I did that x squared and I multiply it times the x minus 2, tell me what I would get. X cubed, right? And then the next one would be minus 2x squared. Do you see the problem? Where am I going to put the negative 2x squared? If I put it right here, and then come through and try and subtract and change the signs, you cannot add negative 8 and 2x squared together. And students start to do that. And what happens is you start to get things that start overlapping, and you get confused. So the workaround for this is that you must recognize in the very beginning of the problem that you are missing an x squared term, and you are missing an x term. They're not there, right? So when you write your polynomial on the inside, you write x cubed plus 0x squared plus 0x minus 8. And all this does is gives you space holders. It gives you vertical space so that when you come to put those things in, they'll have somewhere to go. But in the end, it's just these are zeros, right? There's nothing there. Okay, now let's do this. You said I had to turn the x into the x cubed. I multiplied by x squared. I'll line that up right on top of the x squared stuff. We said when we multiplied through, we got what? X cubed first. Put that underneath the x cubed. And then you said we got negative 2x squared. See how I line that up nice and neat? Subtract. Changes the signs. So what do I have on my next line? X cubes are gone. The 2x squared, nothing here, and negative 8 comes down, right? So I should have 2x squared and then negative 8 back here. Questions? How do you turn x into 2x squared? I multiply by 2x. So I'm going to put that up here, plus 2x. And now you multiply this 2x through to each one of those. So what's 2x times x? 2x squared. I put that right underneath the 2x squared. And then 2x times negative 2 is negative 4x. And look, I've got a space for it, right? Write down this x column vertically. I have space to put that thing. So I'm going to put in there negative 4x. And then I can come through and subtract. Questions at all? Sure. Adding straight down now, what do we get? 4x minus 8. Can I do it again? Can you turn x into 4x? Sure, just multiply by 4. So plus 4, multiply through. 4 times x, 4x. 4 times negative 2, negative 8. Hey, they match, don't they? And that means they're going to cancel. And that means I'm going to have no remainder, which means this is the answer. which really means what? That this x cubed minus 8 could be looked at as being what times what? X minus 2 times x squared plus 2x plus 4. Does anybody recognize that this is a difference of cubes? Yes? The difference of the cubes formula is, if someone were to tell you to factor this using difference of cubes formula, this is exactly what you would have gotten had you used the formula. The formula is x cubed minus a cubed is equal to x minus a, x squared plus x times a plus a squared. That's the formula for difference of cubes. So if you just apply that, replacing your a with 2, you would get that. But again, this is the answer, but thinking ahead, we've actually found a way of factoring something without even using a formula. You see that? Just needed to be able to divide. Okay, what about the next one? I think I'll let you do that on your own. Okay, let's do E. E looks like a good one. So for E, we have x cubed plus 4x minus 1 over x squared plus 1. Now this is the first time that the denominator has not been linear. Do you know what I'm saying or not? Yes? X plus 5 is linear, x plus 4 is linear, x minus 2 is linear, x minus 2 is linear. X squared plus 1 is not linear. So can this still work? Absolutely. Absolutely, this will work. Anything I need to be careful of here? I'm missing an x squared. So I should put x cubed plus 0x squared, then plus 4x, then minus 1. Then out here, x squared plus 1. Now this would be interesting. Think about this. If we're able to get an answer here, right, with no remainder, we actually would have found a way of factoring this. Wouldn't we? Yes? And this is not something that you can factor. X cubed, well, if that was an x squared, you might have hope. But it's x cubed plus 4x minus 1. Nothing has ever been taught to you on how to factor that, right? So if this does work and we have no remainder, we actually have a way of breaking that thing down. Yes? Okay, so does it work though? I don't know. I don't remember. What do I multiply x squared by to turn it into x cubed? X. So I'll put that way over here. Multiplied through, x times x squared is x cubed. X times 1 is x, so I put that way over here. Come through. Add down. Or no, subtract first. Change signs. And now add down, what do you have? 3x minus 1. Yeah, it didn't matter. Well, but we always want to do it because we would not have known that. Now, can you turn x squared into 3x? No, the power on this is now smaller than this. We stop. But we have a remainder, which means that this is plus what? 3x minus 1 over x squared plus 1. The big thing, though, I mean, that's the answer. The big thing, though, here, we did not find a nice way of factoring that, okay? We did not find a way of breaking this down because it did not turn out to be a nice answer. We had this remainder fraction thing here. So I cannot write this as something like this times this equals this. So it's we weren't able to factor it. Oh, well. Doesn't always happen. With me or not? Okay. I'm going to give you f as an in-class quiz. You've got 10 minutes. Work together. It's fine. Separate sheet of paper. Turn it in. Okay? I think 10 minutes is plenty of time. Oh, did I tell you about my rate my professor thing? I read it the other day. Every once in a while I go check it. I had this student complaining about me, saying this guy gives quizzes on the same day that he introduces the material, and we got all upset about it. So, sorry, you have a quiz over what we're doing right now. I don't think it's that much to ask. You're allowed to work together, right? Gets you practicing. It wasn't this class, by the way. It was a different class. All right, I'm going to pause my video. You have the problem in front of you, right? Okay. I'm sorry if that offended you. Well, you have to think about those things, you know. Did y'all hear a couple of years ago there was a couple out in Helotes that they were on a tandem bike, and you know what a tandem bike is? It's both on the same bike, and someone was texting coming over a hill and took them both out. Left 3 kids, I think 3 kids. You know, and that's the type of thing. It's like, nah, it's not worth it. Okay, so look, let's get back to this. This is a little bit happier. So here's the summary, okay, of what we've done up to this point. Long division is an effective method to help us factor polynomials. The problem, though, is something that I don't know if you realize, is that how did we determine what to divide by? Like, if you go back and look at this right here, if I was trying to break down the x squared plus x minus 2, acting like we didn't know how to factor that, I said, look, just divide it by x plus 2, and when you do that, you get x minus 1. Now we know x plus 2 times x minus 1 gives us that, right? But I gave you x plus 2. So how would you have known to try x plus 2 to divide into? Does that make sense? This will come to light a little more, hopefully, as we keep going. So that's a major roadblock for us, is that the long division will help us factor, but we have to know what we can divide by to get this thing to work out. That will come later, all right? Before we get to that, okay, we will resolve that issue soon. Before we get to that, there is a shorter form of division called synthetic division. Now, I heard someone say synthetic division when I put that problem up to begin with. Here's the thing with synthetic division, though. It's limited. You can only use it when you're dividing, your denominator is a linear expression x minus a. It's the only time. Now, it can be x minus 4, it can be x plus 3, it can be x plus 1. It just has to be linear. Then synthetic division works. So synthetic division would not have worked for f. Synthetic division would not have worked for e. Got it? But it will work for A, B, C, and D. So the best way to show you how to do synthetic division is not to give you some algorithm. It's just to actually show it to you, and then you kind of just have to remember the process. So I'm going to do the same problems, okay, using synthetic division. Here we go. So now we're synthetic. By the way, there's different versions of synthetic division. I've seen people from different countries that have like their own like versions that they were taught and stuff. So I know there's a lot of different ones out there. I'm just going to do the one that's pretty standard here in the United States. And what we do, we start off with what we're trying to divide, which is this. And what we're going to be focusing on are the coefficients, not the leading coefficient, the coefficients of each term. So what is the number in front of x squared here? 1. What's the number in front of the x term? 2. What's the number that doesn't have x? Negative 15, right? So what I'll do is I will draw what we would refer to as an upside down division box. Make it kind of big because you need to be able to put 2 rows of numbers in here. Okay, now inside here you put these numbers, 1, to negative 15. Leave a little space between them so you don't accidentally think that's a 12 or something, okay? Then on the outside of the division box right here, I'm going to put the opposite of the number I see here. So I see positive 5, I'm going to put negative 5, okay? Opposite. And I know you're going to be maybe sitting there going, well, why does this work? And I'm actually I'm not here to prove to you that synthetic division works. You just have to trust that it does, and we're going to do it. All right? All right, so now the process begins. We've set everything up. Any questions on the setup? Does anyone know how to do this already? Raise your hand. Yeah? Okay. It's been a while. Okay, so you take the 1, and what you do is you're going to add straight down. And since there's nothing underneath the 1, it's just 1 plus nothing. That's going to come straight down, and we're going to place it right here, 1. Then I'm going to take my negative 5. I'm going to multiply it times this. Multiply, not add. Multiply these together and put that answer under the 2. So it's kind of like I'm doing this. I'm doing that times that, and that's going to go right up there. So what is that? Negative 5? And now the same thing. Add straight down. Okay? This time, no, you're multiplying. Careful. Adding straight down, you're doing 2 taking away 5 is negative 3. And now you do the same thing we just did. You take the negative 5 out here, you multiply times the negative 3, you put it underneath the next number. So I'm going to go negative 5 times negative 3, put that answer here. And you said that was a what? 15? And now add down again. You get 0. This last number is your remainder. This last number is the remainder. So what we usually do is we put this little half box around it so that we know that last number is the remainder. That's always your remainder. We like the answer to have a 0 remainder because that kind of tells us that that thing factored, right? Kind of. So look back in your notes when we did this with the long division. What was our answer? What was our answer? X. It was X. No, the one in the division, not our factor thing. It was just X minus 3, right? X minus 3 was our answer. Where is that here? I mean, it's somewhere here, right? Do y'all see it? This somehow has to do with the answer, okay? Somehow. Now, do you remember how we said that we got these numbers, they were the coefficients, right? These numbers are the coefficients of our answer. So what I can tell you is this. I know that I have a 1 and I have a negative 3. The question is, what is the x that's going to be next to the 1? And what is the x that's next to the negative 3? Well, the way it will always work with synthetic division is that the x that's next to this one is 1 power less than what this was to start. Okay, so this started as x squared, right? That means that what's next to this is 1 power less, so it's going to be an x. And then as we move to the right, the power comes down. So x to the 0, which we don't write. So this is the answer, x minus 3. You follow that? Now, I'm going to move this to the side. I'm going to 1x minus 3. That's the answer. You don't have to write the 1 in front of that, right? I'm just writing it there so you know where it came from. So that's our answer. Now, because of where we're headed with this, all right? Because of where we're headed, I want you to see something else. Do you remember how I was saying that the whole idea here was to try and be able to factor something, right? Okay, I want you to see a way that we can use this chart table thing over here to actually rewrite the numerator factored. So see if you follow this. These two pieces right here tell me that one of my factors is x minus 3, which is the answer to the problem, right? Yes? But this right here gives me the other factor, which would be x plus 5. That what we divided by, right, was x plus 5. We changed it because I told you had to. Think of that negative 5 right there as being the x-intercept, being the 0. And so that 0 creates a factor. What factor does it create? X plus 5. Understand? It did get cold, didn't it? That would be what that top factor is to be, wouldn't it? So, no. The final answer was this. If I'm just asking you to do synthetic division, the answer was x minus 3. But by the end of class, well, I don't know. We are going to do something even beyond just getting this answer, all right? All right. Shall we do another one? Let's do C. C is a little harder. All right, let's start with the synthetic division box. What are the coefficients for that numerator that goes in there? 1, 0, 0, -8. Now, what happens if you forget? Oh, I forgot that there was an x squared and an x that were not there. I forgot. It's going to be completely wrong. You have to account for the zeros with synthetic division. Any questions there? Now, what goes on the outside? 2. Okay, you real quick try and do that thing. You know, add down, multiply, cross, bring up, add down, multiply, cross, bring up. See if you can get the same answer I get. Add down. No? Yeah. What's wrong? What are you're looking at it like? Bring the one straight down. Yeah, once we get, wait, say again? You bring the one down first. Bring the one down first. Then 2 times 1 is 2. Then add down. That's 2. First one's always just going to drop straight down. Yep. No, it won't always be 1. So can you tell me what the answer is from those 3 numbers? Oh, we had a remainder of 0, right? We have to have that for this to work out real nice. What's our answer? X squared plus 2x plus 4. Remembering that this is the coefficient on the first one, right? So there's 1 out here in front. I'll put it there. And then the power is going to be 1 less than what we started with on the top. So it's x cubed. It's going to start with x squared, and then it's going to work its way down. Now, I don't have time to go do another example because I'm running out of time. Let me ask you, if this remainder out here had been 3, let's just say, if we had 3, this would still be the same, here, 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 but then I would have to add on the outside plus the remainder over the divisor, which would be x minus 2. I would have to go back and put this remainder over whatever I divided by. Yes. Then that would be minus 4 here. Yes. Yeah? Okay, I think that's sufficient. Now, let's move back on to this. All right, so back in the fifth note here, I said we would have a way to do this, right? I said we will resolve this issue soon. Like, how are we going to know what to divide by? And what it is called is the rational zero test. And this is from a section that's coming later. This is where I said I'm going to grab bits and pieces. I'm actually going to show you the rational zero test right now without giving you like a real formal like lesson on it. Just show you how it works. All right? So what we're going to do, we're going to take these polynomials and we are going to factor them. I want us to appreciate the magnitude of what we're about to do. This first one is the problem I started class with that I said you could not factor. Every one of these after that is something that you would throw up on if I had given that to you as a quiz to start today, right? You would just no way you're going to factor those. All right? We will be able to do it though. Okay? So let's start with the first one. So I'm going to go back and I'm going to remind you in the beginning of the notes where I told you what the answer should be, right? I told you it should be those three factors. Let's see if we can get to that, all right? Let's see if we can get to that. All right, so how does the rational zero test work? The rational zero test says what you do first, you make sure it's in descending order. You make sure you've factored GCF out. If there's like a greatest common factor, you pull everything out first. Make sure you're at a place where you're stuck, which is we are, right? There's no GCF, we're here. So we're going to identify the leading coefficient, which is 1, and we're going to identify the constant term in the back, which is negative 42. Those two numbers. We're going to look at those, and we're going to investigate those two numbers. We start always with the number in the back, the constant. And I really don't even want you to concern yourself too much with the fact that it's negative. I just want you to focus on the number 42. I'm going to put a colon there. Tell me all the different ways that I could multiply two nice integers together and get 42. 6 and 7, what else? 4 and, I heard 4 and 21 and 2 and 1 times 42, right? There's all these different combinations, right? What you need to do is list out every possible combination. So watch how I'm going to do this. I could have 1 times 42, right? So I'm going to put 42 way in the back like this. I could have negative 1 and negative 42, couldn't I? So what we're going to wind up doing is we're going to put plus and minus on both of these, meaning it could be 1 and positive 42. It could be negative 1 and negative 42. So every time we do this, no matter what, we're always going to look at plus and minus for each one. How about 2? 2 and 21. 2 and then back here, plus or minus 21. How about 3? 3 and 14. How about 4? 5, 6, 6 and 7. Now the next number would be 7, but we already have 7, don't we? So what happens is as you make this list, they kind of come in and you get to the point where you've exhausted all the possibilities. We're looking for integers only, okay? Which is why the name of this thing is called the rational zero test. We're only looking at rational numbers as possibilities. Okay, so look, that's the first thing you do. The next thing you do is you look at the number 1 in front. And you write that down. And then you list out all the different ways you can get 1. 1, plus or minus 1, that's it. So we get, whenever it's 1 in front, it's like the best case scenario because it's so simple on the second one, right? Now, if that had been a 5 or a 4, we'd have to list out all the different factors. Okay, so does everyone understand we've created 2 lists of numbers? Now, to come up with our final list, I'll put it in red, we're going to have a final list of numbers here that we're going to work with. What we're going to do is we're going to take every number in this list and then divide them by every number in this list. So I'm going to take plus or minus 1 and divide it by plus or minus 1. What would that be? Still plus or minus 1, right? I mean, you would either get 1 over negative 1 or negative 1 over 1 or 1 over 1 or negative 1 over negative. You'd still get, the only possibilities that you would get out would be positive or negative 1. What about the next one? How about 2 over this? So 2 or negative 2, right? Do you get what's going to happen here? 3 over this? I mean, it's the same list as the top one, right? Now, what if this had had a 1 here and then a 2, though? Like, let's just say this also had a 2. It doesn't, but what if this had also been plus or minus 2? Then you would have to do what? 1 over 2, which is 1/2. Then you'd have to do 2 over 2, which is 1. You already have 1 in the list. 3 over 2, which is 3/2. So you'd have to put that in your list. 6 over 2, which is 3. We already have 3. Do y'all follow me? So when we see 1 out here on a problem, we're like, yes. Because our final list is going to match this list. They're going to be the same list. So let me put them out here. Right? Okay, this is fun. Now, how are we going to factor this thing? I mean, it's like, what in the hell are we doing here? Well, do you remember how we said that, and just now, in the previous note, we said that if we knew what to divide by, right? If we knew this, and we turn out to get a 0 out here, we know how this factors. Let me go to the previous one, right? If we started with this and acted like this wasn't here, right? If I just randomly would have just said, hey, let's just try negative 5, and it would have spit out a 0, it told us that this would happen, right? Well, guess what this list of numbers gives us? All of the potential candidates that we should try, one by one, until we get a 0 in the synthetic division. Understand? That sucks. Okay, so what's that? If it is factorable over the rational numbers, yes. It would not help us with that x squared plus 4 that we had earlier. Could not handle that. Can't handle it if the x-intercept or the factors are irrational numbers, like square root of 2. It won't work. Okay, so I know that this seems like, seriously, we really have to, yes, you really have to do this. So let's set up a synthetic division box. Let's look at what is the polynomial that we're trying to divide. Well, this one right here, right? So what are the numbers here? 1, 8, 1, negative 42. And there's no zeros in there or anything, right? So 1, 8, 1, negative 42. And where should we start? Well, let me tell you, because this list is long, right? I have to try what each of these represents 2 numbers, 2, 4, 6, 8, 10, 12, 14, 16 possibilities, right? And if you're taking a test and you start just randomly picking these, you could be there for a while, right? So what I'm going to tell you is this. When you're on a test and you make your list, put them in order from smallest to largest, just like I've done. Start at the beginning with the smallest, and I promise you it'll happen within the first 6 tries. Okay? But if you start randomly picking things, you may be there for 15 tries before you get it. All right, so what I'm going to start with is positive 1. I'm going to put positive 1 out here. I'm going to do synthetic division. Now, we have to become quick with synthetic division. That's the whole point of it, is that it becomes fast. So bring your 1 down. 1 here. 1 times 1. 1, add down. Multiply. 9 times 1. 9, add down. 10, multiply. 10, remainder, not 0. Did not work, right? Because this remainder is negative 32. That means I don't want that to happen. Yes. Yes. That's the order we're going to go. 1, then -1. It's not, it could happen. It could happen that if 1 doesn't work, -1 could work. All right, so let's do -1 now. That's the order you should go in. 1, -1, then we'll go 2, -2, and then whatever's next. So -1 out here now, 1, 8, 1, -42. So what do you get? 1 comes down. This time, -1, add down. 7 multiply, -7, add, -6, 6. Is my remainder 0? No, it's -36, right? Not happening. So now we go to 2, and then I'll do -2. So let me try 2. I know you don't like this, but I mean, maybe you do. Make sure I get this right. 1, 8, 1, -42. So what happens if you accidentally write this down wrong? You're screwed. Yes. Okay, 1 comes straight down. 2 times 1, 2. Add down 10, 20, 21. Oh, 42, 0. Yes. Right? Ding, 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 ding. Right? We won. Now, the important part of this now is how do we interpret this table to create our factored form? So let's try and see if you can recall what I just talked about a minute ago. What do these 3 numbers represent? The coefficients of our answer, which would be what power on x? 1. What did we start with? It was cubed, right? X cubed. So this is going to be x squared. Then what? Plus 10x, then plus 21. Now here's the critical point. What does this piece tell us we have as a factor out here? X minus 2. So would you agree we have, in essence, already factored this thing part way? And do you agree that this is a quadratic, it's a trinomial? And you could do that with AC method, or whichever way you're comfortable factoring trinomials to start coming into this class. You should have been able to do that. I don't know. I hear people say it. No. It's a method of doing this. A lot of people do it mentally, but some people do it with like a method where they do a little like cross and figure out what A times C is. And like they do, what's 1 times 21 is 21. And then the number in the middle is 10. They try and come up with 2 numbers that multiply to be 21, add up to be 10. 7 and 3. Yeah, so 7 and 3, and it turns out that the 7 and 3 are the ones that'll work. But it's a little more complicated than that. But that's the method, it's AC method. But remember, the part that's highlighted here is the part that I expect you could do, right? So all we did was the synthetic division allowed us to just get past that first hurdle of breaking the cubic down to a quadratic. And does that match what we plus, yes, thank you. Plus 3 down there. Does that match what I said it would be? Yes. No, no, no. See, I'm not asking you to divide. I'm saying factor this thing. Okay? Your homework is going to say divide, 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 you know, and that will just be what we did in class. One short or long method? What are they? What are what? Yes, there are 2 different sections in the book. So the first homework assignment is going to come out, and it's going to be long division, second one synthetic. Okay, I have 5 minutes. Well, do we have time? I don't think we do. I'm sorry? This will not be in the homework, what we're doing right now. So I have a lot more to do here, right? I have a lot more to do, but I still have 4 minutes. So I'm going to try and start this one. Come on, come on. We're here to the end. What is it that we're trying to factor? X cubed minus 21x minus 20. Okay, so you look at that initially, you try and pull a GCF out. You can't. It's not a quadratic trinomial, right? So you can't do AC method. You're stuck. You go drop the class, right? Can't do it. So, no, you realize that there's a 1 in front here, right? There's a 20, and you're happy to see the 1, aren't you? Because that means that your final list is really just all the factors of this last number. So I'm going to go straight to the final list. Only because, why? That's a 1. And do I give you an example where, the only example I give you where it's not 1 is F. We're going to do that next class. So help me with my list. All the factors of 20. 1 and 20, 2 and 10, 3 doesn't go in. So I start just going through all the numbers. 3 doesn't go into 4 and 5. Oh, and I'm done. As soon as I meet in the middle, I'm done, right? Because after 4, I'd go to 5, but I already know 5 and 4, so there's nothing else that's going to work. So I've reduced this down to 2, 4, 6, 8, 10, 12 possibilities, and I'll start with 1. Synthetic, careful. 1, 0, right? Negative 21, negative 20. Starting with 1 on the outside. Is this going to work the first try? Who does that? Who does that? Okay, so 1, it was by design. Oh, wait, hold on. No, this one's not going to work. It's the negative 1 probably it's going to work. Right, that doesn't work? Be careful. 1, multiply 1, add down 1, multiply 1. Negative 20 times 1 is negative 20. Negative 20 added to negative 20 is negative 40. And that doesn't work. Try negative 1. So 1 comes down, multiply negative 1, add down negative 1, multiply 1, negative 20, multiply 20, remainder 0. So if you feel that level of joy, that's fine with me. So what do these 3 numbers tell us? X squared minus x minus 20. What does this in front tell us? X plus 1. Can you factor this? I hope so. Yes, it's a quadratic trinomial. 2 numbers that multiply to be negative 20 and add up to be 1. Minus 5 plus 4. Okay, got it? We just factored that thing. That didn't take too long, right? Now, I know you want to go. Okay, you got to give me 1 more minute. I'm looking at the clock. I got 1 more minute. Just turned over. I'm not going to do a problem, but I just want you to appreciate this. Look, some of you who have trouble factoring this, that's what we just had up there, and you had trouble, right? Maybe? Okay, let's act like you don't know how to factor that. So you come in here with this new rational 0 test. You look at the number in front, 1. Look at the number in the back, 20, right? And you start, and you create a list. You start going through the whole list. Right, wouldn't this list be the same list we just had? Okay, and you start going through them, and I promise you that when you get to negative 4 on this list, so you would have had to have tried 1 and negative 1, 2, and negative 2, right? You go through it, but when you get here, those would have been the numbers in your synthetic division, right? You would have had 1 here, negative 4, negative 5, and when you multiply there, you got 20 and 0. So what does this tell me? X minus 5 here and x plus 4 here, and that's what we got, right? So in other words, this is a method you could have used to factor quadratic trinomials had they had the desire to show you this method, which I think they should have shown you a long time ago. But all right, so we are going to become factoring magicians now with this method. Next class, we will do the homework that's scheduled on your schedule for today. Do that homework for next week. We'll pick up with this when we come in next time. Y'all have a good weekend.